In the last video, in this bridging section, we looked at the idea of the sine rule. What we're now going to introduce is the cosine rule. Again, this is for non-right angle triangles for finding missing sides and missing lengths. So this time, if we get another non-right angle triangle, what we use the cosine rule for is when we have an enclosed angle. Okay, so if we've got the enclosed angle and we're given these sides here of C and B, or B and C, whichever way around you want to do them, and this is big A and little a, then what we've got is an enclosed angle, and we might be given the values of C and B, and we need to find the values of A. So this enclosed angle requires the cosine rule. The cosine rule says that A squared is equal to B squared plus C squared minus 2BC cosine A. That will get us the missing length A, or it will get us A squared, and we just have to square root it. So you could say A is equal to the square root of all of this. This is for the missing length. So we'll be able to spot this if we have an enclosed angle between these two lines. Now let's look at the finding a missing angle. We find a missing angle in the following way. You can manipulate this formula right here to find that, and I'll show you how to do this. But for a missing angle, what we can say is cos A is equal to B squared plus C squared and then minus A squared over 2BC. So this right here will give us a missing angle in that non-right angle triangle. If you weren't happy with that and you wanted to derive that little formula yourself, then what you could do is the following. You could add the 2BC cos A to both sides. So we'd have 2BC cos A and then subtract the A squared from both sides. This will give you B squared plus C squared minus A squared, and then divide out by the 2BC. So cos A is equal to B squared plus C squared minus A squared over 2BC. If you can remember that is the result, then that's absolutely fantastic. Remember, that will give you the cosine of A. So if you want A, you're going to have to do A is equal to cos to the negative 1 of B squared plus C squared. So B squared plus C squared minus A squared, so that should be A squared, shouldn't it? A squared over 2BC. So there we go. Let's look at this in action then. So automatically, let's have a look. We can see that we've got an enclosed angle. That's an enclosed angle right there. So what I'm going to do, I'm going to ignore the E's, the F's and so on. I'm just going to pull the information that we need from this triangle. Often when you start with, it's a lot easier just to sketch this up away from all the labelling. And we've got 43 degrees here, which is the enclosed angle. And then we've got 8 and 5. Now we want this one just here, okay? So if I call this little a, this big A, this will be little b, and this will be little c, okay? So trying to find a, we can say a squared, or a is now equal to the square root of b squared plus c squared minus 2bc cos a. So a is going to equal the square root of b squared. Well, b squared is 8 squared, or 64, plus c squared, which is 5 squared, which is 25, minus 2 times by b, which is 8, times by c, which is 5, times by the cosine of 43 degrees. And again, check you're in your degrees mode in the calculator. So let's push this through the calculator and see what we get. Okay, let's grab it up. So we want the square root of 64, and again, check you're in degrees mode. It says a little d up there. If you're not, change it. 25 minus 2 lots of 8 times by 5 times by the cosine of 43 degrees. 5.5, we're doing it to one decimal place. So 5.5, and that's going to be in meters. Okay, let's have a go at another one. Right, this one right here, what I'm going to do is redraw this information to make it slightly easier to see. This time we're working in centimetres, and what we've got is the enclosed angle of 35. So 35 degrees. This side of it is 11, this side is 16, all in centimetres, and we need to find this one. They've called it x, I'm going to call it little a. So here's big A, the angle A, here's B, and here's C. So we now know that A is equal to the square root of B squared, which is gives us 11 squared, which is 121, plus C squared, which is 16, which is 256. And then we're going to have minus 2B, which is 11, C, which is 16, cosine of 35 degrees. So whack all that under the root, and we will get the value of A. So back through the calculator, we're in degrees mode, we know that already. So it's a square root of 121. You don't have to write the full ones out, you can just put 11 squared. I just think it's important to keep up with my number skills and remembering things. And then cos of 35 degrees. Okay, and this will give us our answer, so we can put that straight through, and we see that it's 9.415, so we'll just call it 9.4, and that's going to be centimetres. So there we go, that's the cosine rule for finding a missing length. And as with all the other tutorials, there's a lengthy look at this on my channel. Okay, let's now see what we've got. Okay, we're going to find the missing angle. Now, if we look at this one, what we've got is the enclosed angle is at the top. So let's sketch this first triangle, and it'll give us some idea. We're after that angle. So if we call that angle here A, big A, then we've got little a down here. Little a is equal to 14. We can see that B is going to, A is going to equal 8. My apologies. Let's change that over. 8 down here. So little a is equal to 8. B is going to equal 14, and then C is going to equal 10. So what we can say then is A is equal to cos to the negative 1 of B squared, which is going to be 14 squared, plus C squared, which is going to be plus 10 squared, and then minus, on here, A squared, which is going to be 8 squared, all over 2BC, 2 times by 14 times by 10. No need to simplify it, we'll just push it straight through the calculator and come up with an answer. So, shift cos to the negative 1 of 14 squared plus 10 squared minus 8 squared all over 2BC, which is 2 times by 14 times by 10. And the way you put this in a calculator is entirely up to you, as long as it holds true. And that will give me the angle. The angle is 34 degrees, correct to one decimal place. So 34.0 degrees. And that is that angle right there. Let's do one last one. Hopefully you're seeing where this is going. So all we're doing now, we'll do one with the nice numbers, make my life a little easier. We'll do this one. So what we've got, we're looking for the top angle. So top angle we'll call A. This one, A down the bottom, is going to be 8. We'll call B 6. And we'll call C 5. So what we know is for A, the angle is equal to cos to the negative 1 of B squared, which is going to be 6 squared, which will give us 36, plus C squared, which is 25, minus A squared, which is minus 64, all over 2BC. Okay, so we're going to get this value here, 2BC, so it's going to be 2 times by 6 times by 5. And if we put that straight through the calculator, we'll get the following. So this looks like it's going to be over 90 degrees. So let's just do shift cos of 36 plus 25 minus 64 all over 2 times by 6 times by 5 to give us a total now 92.86. Okay, so 92.86, that'll get rounded to 92.9. So 92.9 degrees. And when I said that's going to be over 90 degrees, it's because this has given us a negative number. And just to go back, you don't need to be on the ball 100% with this, but if we look at the cosine curve, if we think about the cosine curve, what we're going to have, the cosine curve starts here at 1, it comes down to pi by 2, or in our case 90 degrees at 0, and then it's negative from 0 back up, from this point here, 90 degrees. So anything beyond 90 degrees is going to give us a negative cosine, up to a certain point, okay, but in terms of a triangle. So there we go, that is what we're doing. So the take-home message is that we use the cosine rule when we've got an enclosed angle and we need to find a missing side, or when we're trying to find an angle given 3 sides. Arrange it like so, you can sketch it up, and essentially just keep on top of your basic algebra skills and number skills. What we'll do in the video coming up, we will look at combining the cosine and sine rule to solve some problems.